Now let's try practicing this. Sodium, the metal, gives out an electron and turns into the positive ion, sodium ion. And the other thing that comes out from it, it breaks down essentially just by removing a small piece. That electron comes out, and this particular electron goes to chlorine, right, which ends up forming Cl minus, right? And now these two have, because they have opposite charges, will be held together with ionic bonds. So we got to show that. And how we show that, the electronic arrangement only, is we try to, now we're going to focus on the outer shell only, right? The outermost shell. Now what is the outermost shell for sodium ion? What does that look like? We're talking about the ion, we're talking about the end product. Okay? It has no outer shell. It's gone. Okay? And on the other side we have chlorine, which has a negative charge. Okay? And we got to show its electrons. So it doesn't have electrons. It doesn't have it does have an outer shell. So let's draw that. Let me get a all right, can I move this about? Okay, like that. Okay. And let's draw some electrons on it. Okay. Now chlorine has 7 electrons, and I'll draw them in pairs because it's easier for me and easier for everyone. So you draw them in pairs. Now 4, 6, 1 more. Okay. But we're not talking about the chlorine atom. We start with the chlorine atom, but we're specifically talking about the chlorine ion. Chlorine ion took 1 of sodium's electrons. So I can draw another electron here, and that'll be it. But I also want to emphasize, make this more knowledgeable diagram, a more informative diagram. And I do that by suggesting that by highlighting the sodium's electron by representing it with an X rather than a dot. So this is highlighting that chlorine has 7 electrons of its own and 1 extra electron from sodium. Okay. Chlorine has 7 electrons of its own and 1 extra electron from sodium. And now we put the brackets in. The brackets kind of like that. It's off center, which I find it annoying because the chlorine is a little bigger than I anticipated. And there's a negative charge on this chlorine and a positive charge. This is how you show the charges. Let me just erase this sodium and rewrite it in the center. Otherwise my OCD won't let me sleep at night. Okay. And that's how you draw the dot and cross bonding for sodium chloride, the ionic bond. Okay, let's move on. What is an ionic bond? An ionic bond is the electrostatic, they're caused by electrons, so electrostatic force of attraction between what? Between oppositely charged ions. And if you, for kicks, you can also add in an ionic compound. Sir Abul, that's really easy. That's straightforward. But what if you had an ion that didn't have a positive charge? It had a double the charge, 2 positive charge. So let's take a look at how magnesium chloride bonds ionically. MgCl2. Now magnesium forms an ion with a 2 plus charge, whereas chlorine, we've already seen, forms an ion with a negative charge. So they're not too compatible, are they? Right? So what they end up doing is, let me just draw the electrons. So this likes to give, and 2 electrons, and chlorine will gain 1 electron. So 1 electron and chlorine. Okay. Now, how do they end up bonding? So what ends up happening is kind of straightforward. Magnesium would really like to lose 2 electrons, right? We've seen this before. Magnesium really wants to lose 2 electrons. So if it wants, because it's in group 2, right? 2 outer electrons. So what happens to the extra electron? Well, nothing really. What ends up happening to it is the same what happens to sodium's electron. But instead of giving one of its electron to chlorine, it gives 1 electron to chlorine, and that gives it a negative charge. And where do you think the second electron goes? The second electron goes to another chlorine, and they form an ionic compound that way. And that makes sense because the charges are balanced out, and that way the ratios are kind of balanced out. What does MgCl2 mean? MgCl2 means for every 1 magnesium there are 2 chlorines present, and that makes sense. For every 1 magnesium, because it gives out 2 electrons, you need 2 chlorines to kind of cater to its needs, right? To take 1 electron each. Okay. So that's magnesium chloride, and we'll see in a bit what the dot and cross for this is. But let me draw a line and talk about magnesium oxide, let's say. Let's have a look at magnesium oxide. Magnesium oxide is made up of magnesium, which also forms a magnesium 2 plus charge, the ion. Oxygen, being in group 6, does what? Gains 2 electrons to form a negative charge. So magnesium will lose 2 electrons, whereas oxygen will gain 2 electrons. And their charges are also balanced. So what's going to happen to them? Well, what magnesium does is, what it does to oxygen is, it gives 1 of its electrons to oxygen, and so does the other one, because it can accept up to 2 electrons. So let me just try showing oxygen atoms over here already. So oxygen's atoms are blue in color, and there'll be 6. Okay. And just to show you guys, we'll remake the dot and cross. Magnesium gives its first electron and it enters oxygen's orbit. It's a valence shell, and I'll put that in pink, and then the second one comes in. So now magnesium has lost 2 electrons, and now it has a net charge of 2 plus on it, and oxygen has a net charge of 2 minus. If right now I erase the arrows, I can turn this into a dot and cross diagram. Let's try doing that. I erase these and get some gray out like that. And I mean, Picasso couldn't have written this down more neatly or more aesthetically pleasing than what I did just now. Right? Okay. But what happens, how do you end up showing magnesium chloride? Like, I think we all know what's going on here, but how do we end up showing the 2 electron thing? So let me scroll down a bit. Alright, let's talk about magnesium chloride now. Magnesium and chlorine. Now chlorine has, staying true to the colors, chlorine will try drawing in pink. Chlorine has 7 electrons, 2, 4, 6, 7. Okay, now each chlorine takes 1 electron from magnesium. Magnesium on the other hand has no electrons around it. So let's try drawing the brackets around. And that's one bracket, that's another bracket, that's one bracket, that's another bracket. Now to make it neater and skip a step to draw another one, we just put a 2 over here. 2 electrons. You have magnesium 2 plus with 2 chlorine ions with each having a negative charge. Okay. Some more questions. Explain why a magnesium ion has a 2 plus charge. Why does it have a 2 plus charge? It's in group 2, 2 outer valence electrons. It would really like to lose those 2 electrons rather than gain 6 electrons to have to have an outer shell of 8 electrons, right? So the easiest thing for magnesium to do is lose 2 electrons. The ions in magnesium oxide stay together. Why do they stay together? We just saw magnesium oxide. Magnesium has this is what it looks like, MgO. Magnesium has a 2 plus charge, oxygen has a 2 minus charge, and these ions are attracting each other because of their opposite charges, and they stay together. This attraction is known as what? An ionic bond, right? Okay. Magnesium chloride has no overall charge, or any of these compounds have no overall charge, because the sum of their charges add up to each other's value, or the sum of their charges cancel each other out. So there's no, like if you hold a grain of salt will have millions of sodium ions and millions of chlorine ions, but they'll be in equal number, right? So the net positive charge on it and the net chlorine negative charge on it will balance each other out. So overall there's no charge. Take it. The formula for magnesium chloride is MgCl2. We just saw this. Magnesium likes to give out 2 electrons. Chlorine can only take up to 1. So you need 1 more chlorine to balance that charge out. So it balances it out when there's an uneven number. So it does that. Okay, and we're seeing it right now. Or saw it with magnesium chloride in the example. It balances out. Okay.